Good morning, good evening, good afternoon, whatever time it may be for you guys. I hope you're having yourselves an awesome day today. We're going to be building ourselves one really big deck. This is a composite deck, so it's a little different from the regular stuff we've built in the past. We're gonna be taking you step by step through the entire process so you guys can build yourselves your own deck. Now, before we get going, I have to give a big shout out and thanks to Moisture Shield. This is the product we're using on this deck, and without their help, we could have never done it, because I'll be honest with you guys, we didn't really know what we were getting into when we started this thing. Guys, this is going to be a very thorough two-part video because I want to cover every detail. If you guys go out and attempt to build a deck like this on your own, I want to make sure that you can use this video as a reference and help you along the way. In the first video, we're going to cover demolition, excavation, prepping the grades, which is huge, and a lot of people miss this one point, and then we're going to frame in the deck. On the next video, we're going to cover some of the deck framing details that when you go to build a composite deck, a lot of people miss, including us. We want to make sure that you guys have all the information so you can start out on the right foot. Now, you guys may not need a deck that's quite this large, but I did to entertain all of my friends. So let's get this party started. Now I want to talk about deck design. If you already have a deck there, you guys can come up with something completely new and unique. But what I see a lot of people doing is removing an old deck, putting up a new deck with the exact same design. I want you to think of it like this. Once you remove the old deck, it's a fresh start. You can do absolutely anything that your imagination or heart desires. So don't be afraid to start to think outside of the box. Now, the first thing that has to be done is the demolition and removals. This existing patio is made out of two things: retaining wall blocks and paver stones. What I find is a lot of customers try to save and reuse those retaining wall blocks. I'm going to caution you, when you have the chance, just get rid of them. Nobody really wants secondhand retaining wall stones. Now, on this project, we did save and reuse all of the paver stones that were in the patio. The concrete blocks themselves, those went into recycling and ground up into road base, so they did live a second life later on. So after we've palletized the paver stones and gotten them out of the way, it's time to take that old retaining wall block, put it into a dump truck, and haul it away to get recycled. And yep, our tires were bald and the site was muddy and wet, so we sure couldn't get much traction, which made our job a lot more difficult. What we were able to do is harvest some of the existing sand from below the patio. We spread that throughout the mud, and that gave us just enough traction to help us keep working in these conditions. Alright guys, the very next thing we're going to do is actually talk to a building inspector to find out when we need a permit and when we don't need one. Because after all, if we don't need a permit, we can avoid all the extra fees that the city likes to tack onto our projects. Alright guys, I got Mike on the line, and he's actually the building inspector, and we're talking about the difference between attaching a deck to your house and leaving it separate. There's different requirements. So Mike, when you have a deck separated from the house, can you walk us through the requirements?
Well, yeah, what the building code says, if you're less than 30 inches above grade and not attached to the house, you don't need a building permit unless that deck is in front of a required egress door, which would normally be your front door. So if you're building a deck at your front door, you got to have a building permit because there are other requirements.
So on a deck that's not technically attached to the house, you don't need frost footings. You can just put in standard footings. You don't need a building permit. But if we attach this house, if we actually attach this deck to the house, everything changes, doesn't it?
Yes, yeah, even if well, then a building permit is required, because now you have to have frost footings because you're attaching to a structure that has frost footings and it's not made to move. The thing about building a deck without frost footings is it'll move a little bit with freeze thaw, which is not desirable when you're attaching it, because there'll be a hinge point at the house, and that could loosen up over time.
So once we get the demolition complete, the next thing to do is to prepare the soil that's going to be beneath the deck. that needs to be pitched away from the structure. So when you look at this grade behind me, it looks like it's got a nice taper running away from the house. But actually, it's the reverse. Right now, the grade runs into the house. Looks can be very deceiving. That's why we're gonna be using a laser to make sure that we get all the grades established. If you don't have a laser, you can use a level and an 8-foot board to help you achieve your grades. Just simply pitch your board the way you want it, put the level on it, make sure that it's flowing the right way, and you're in business. But let me show you what I mean with the laser. Now we're going to take a reading right at the house, and this is going to establish our point that we want the water to flow down and away from, on an average of 1 inch a drop per every 8 foot of run. Our first reading is coming in at 3'6". As we go further this way and the stick drops down, the numbers should get bigger. If they do the reverse, then our grade is set the wrong way. Now this should be saying 3'8", 3'9", 3'10". But instead, it's saying 3'5", meaning that we've, instead of going down, we've just came up 1 inch from that point. Now let's see what it says right here. 3'2", 3'3". So we have come up 3 inches from this point to that point. Even though it looks like it's going the other way, it's not. The laser is telling us that this grade is coming up instead of going down. Now our eye's telling us one thing, that the grades are flowing the right way, but the laser's telling us something completely different. And that means that this entire area right here needs to be shaved down. I'm gonna trust the laser before I trust my eye. We wanna make sure that all the water underneath the deck flows the right way. Hey guys, I want to jump in here and remind you to go visit Moisture Shield's website, because if it wasn't for those guys, this video wouldn't be possible, and I know this is going to help a lot of you guys build your own decks. So go check them out at moistureshield.com. Now guys, it's really important to establish the subgrade before you put your first footing in place, because once the footing's in place, you can't alter or change those grades very easily. Now that we've got all the grades set, we can begin the process of putting the footings in and the framing for the deck. We're using green treated lumber for the framing. This is the same material that we would use for a standard deck, but how we actually build the deck is different for composite than it is for other types of decks. Now we don't technically need frost footings for this deck because we're keeping it independent from the house, but I can't convince Frankie to do anything without over-engineering it. So he wanted to have at least a 42 to 46 inch frost footing with a concrete bottom. That's what you're seeing us do here. On a side note, we hand dug a few of these footings and took us hours just to do a single hole. This auger on the front of this skid loader can do a footing in under 30 seconds. It was well worth the investment. Frankie's got us pouring 17 footings for a floating deck. He loves over-engineering.
It is it's not going to be floating with 17 footings.
It's not going to float a whole lot. 4 feet deep.
But it ain't attached to the house.
It's not attached to the house.
And it's holding the house up in worst case scenario. I'd really laugh if you fall.
I wouldn't laugh if I fell.
No, but you gotta really send. That's how I make it big on Instagram, is when Dirt Monkey falls in a hole.
So the bottom of each footing does get concrete mixed and poured into the bottom of it, so we have a solid foundation for the post to rest on. Once the concrete is dry, the posts can be put in place. So to make sure that we got these posts exactly on line, we're running a string line, and then each post has, what is this called, a corner level, Frankie?
Post level. I call it a post level.
A post level, okay. And you can see that we have the focus with the post level that way.
And as one guy's watching it, you know, you can always, one guy's always making sure it stays level.
Yep, and as we backfill, we're getting a titch off. We can adjust it up.
What are you doing, Frankie?
Marking our, where we're running knots are 6x6s. We put these up there to level across. Made sure we were an inch and a quarter below our door sill. That way once we do our notching, we'll be below and everything's nice and level.
Awesome.
So Frankie has built hundreds of decks, and this is one of his favorite construction methods. Is he likes to notch the posts and then rests the header beams directly on top of them, and then also to secure the header beams onto the posts. You'll see that this interlocks every post and every beam together in a row. So notice here that all of the cuts are offset so that when the next beams go in place, they lock together. Now we're going to look at the second row of support beams, and you can see that he actually has these gapped intentionally. They're still resting on the beams, it's still notched, but that gap allows the weight to be distributed a little better.
What are you doing there, Frankie?
Doing the layout on a 16-inch on center.
All right, so all of our joists are 16-inch on center. It's a lot of joists.
Yeah, but it's a big deck.
It is.
And you just got to remember when you do your very first measurement on your 16-inch on center that your first board is at 15 1/4, and then measure off of that mark continuously, and everything will be on center.
So 15 1/4 first mark, and then from there you measure from that mark the whole way down, and everything will be 16 on center.
Yep.
Perfect.
Yep.
Right here in this end beam, I want to show you why we staggered this cut. You can see how it locks together tight. Now as we walk past the framing of the deck, I want you to see how the joists rest on the beams, which rests on the posts. Everything is locked together, so your calculations for your ultimate deck height come from the ground up. All right, let's look at a few of the details on this job. Now, with joist hangers, these are called an 810 joist hanger, Frankie.
Yep.
And what's this? What do we need to know about a joist hanger? Anything particular?
Well, they keep your joist straight up, you know, plumb. Attach it to the sill plate so no movement. Pretty much it, you know. It keeps you on your center with 16 on center, 2 foot on center.
16 on center.
Nice and tight.
Hi, Elliot.
Hello.
16 inches on center. Why don't we go 24, Frankie?
We could have, because we went with 2x8s. We could have, but I went with the extra support because it's just so big. Hot tub down there, just to have the extra support.
Everything is always double sill plated all the way around the perimeter of a deck, correct?
Correct.
So that's the point with. Let me slowly walk over here. Hopefully I don't fall through. If I do, the camera's rolling. It'll be probably pretty funny. Not for me, but for you guys watching. Okay, so why do we double sill plate the perimeter, Frankie?
To hang your post on if you're doing a wood hand railing. Some people attach their lattice to it. It just gives you more support. I mean, more nailing.
Nailing support,
yeah.
Right?
Yeah.
One of the other things too, when we're double sill plating everything, the inner board, here's an important point. Here's a double sill plate. Tell me about this inner board resting on one of the joists. Can you tell me that, Frankie?
On here?
Right there. You see that right there?
Okay. Oh, okay. We always split on a joist just because support. I mean, you don't want to cut your seam out between them because then you have no support on your seam. Your first board is more or less weak.
On your inner board. But now on your outer board, right over here, Frankie.
Yep.
You didn't do that.
No, don't need to because it ain't connecting to a joist. I mean, this one, the second board is just for support and to keep your everything straight.
Okay.
And level.
So now let's look at the subframing real quick. Underneath this deck, you have 2 main support beams.
Correct.
Why not just one big one, Frankie?
You could run these together, but I just like the wider, the more support. Just common sense, you know.
Distributes the weight.
Yep. And then also you got to check your span chart. See, now we are 9 feet out, and 2x8s can handle the 9 feet. Otherwise, if I was going to go with 2x6, I would have to put these probably every foot. You got to do a span chart.
Because you have a 9-foot run, a 2x8 can handle that. A 9-foot deck run with a 2x6, you'd be worried about that
Yep.
you'd be worried. Now it'd probably be fine, but we're talking about Frankie, guys. All right, let me be very straightforward and brutally honest about this man right here. He over-engineers, overbuilds everything that I've ever seen. But how much stuff have you had fall down, Frankie?
None. No.
And that's all Frankie ever does is build stuff day in, day out, job after job.
When he's not leaf blowing.
When he's not leaf blowing. So a 2x6 in this application you could probably get by with, but you got to check your span chart. This isn't something you guess on.
Right. Yep.
Okay, so that's good to know. All right, we're looking at a screw up right here, right? I mean, this isn't the end of the world because we've got support directly underneath it. If you guys want to flame me about this screw up, go ahead. I just won't invite you over on my deck, plain and simple. Right?
Yep.
So here it is wrong, and here it is the right way. Okay? I mean, that's literally now night and day, right? Boom. You can see that it's zigzagged, right? I mean, I love this example. So, you know, I'm glad this happened so everybody else out there can see the difference. So here it is on a 45, not quite right. Here it is the right way. You can see that he zigzags his 45 here and then over here again. We call these hurricane clips. I don't know the technical name.
Rafter tie.
What?
Rafter tie.
Rafter ties. That's fine. And you're putting them in every other.
So one here. Well, actually, this is a good example of how it looks.
Okay, so everyone gets one.
Correct. Everyone gets one, and then the beam behind you gets them. So every beam gets, every joist on every beam gets a clip.
Gets a clip. And what's the point to that clip? You know?
It holds them stationary. It holds them so they can't twist or bend. So it just adds structure.
Add structure to
And
the
then
structure.
you put your deck boards on top. It'll hold the tops of the beams.
Yep. So here's a good example of what he's putting in.
Well, the official name is rafter ties, but One Finger Frankie calls them
hurricane clips.
Hurricane clips. Apparently, he first found out about these when he was working in Florida, and they had to use these on everything they did. So not just decks. I mean, they would be doing them on joists, on
We have
rafters.
hurricane clips on the roof. That's pretty typical.
Yep.
So that word of wisdom comes from One Finger Frankie. And if you want to know why we call him One Finger Frankie, well, subscribe, because we'll probably have a story about One Finger Frankie coming up.
Yep. It's a good story.
He never had.